Example 1.3.2, another inclined planes example. A particle of mass m is pushed up a smooth slope inclined at an angle of 30 degrees to the horizontal by a force of magnitude 5g newtons acting at an angle of 60 degrees to the slope, causing the particle to accelerate up the slope at half a meter per second. Show that the mass of the particle is this expression here. A lot of information in that first sentence. Let's break it down slowly. So diagram, always draw a nice clear diagram. So there's horizontal line, here's my slope, and the particle, doesn't matter what it looks like, I always tend to just draw a rectangle to represent the particle. So mass of m, it's being pushed up a smooth slope, so it's smooth, so there's no friction on the slope. And the slope is inclined at an angle of 30 degrees to the horizontal. So there's 30 degrees on my diagram. The particle is being pushed up by a force of magnitude 5g newtons acting at an angle of 60 degrees to the slope. So the force pushing it is acting at 60 degrees to the slope, not to the horizontal, but to the slope. So let's put this force on. So there's a force pushing the object, and it is acting 60 degrees to the slope. I've drawn the force so it's not horizontal. That's because it won't be horizontal. If the force was acting at 30 degrees to the slope, then it would be horizontal. But 60 means it definitely isn't horizontal. So I've drawn it so it isn't. Let's put all the remaining forces on. There'll be the weight of the particle, mass times gravity. The particle is on the slope, so the slope is pushing back on the particle. That's the normal reaction force, normal meaning perpendicular to the slope. So two things, make sure your weight is vertical and make sure your normal reaction force is perpendicular to the slope. That's it, there are no more forces. 5g is the strength of the pushing force. I don't tend to put units on my diagram, it just gets a bit too messy, but always put units in your final answer. Let's put the acceleration on the diagram. It's the force is causing the particle to accelerate up the slope at half a meter per second every second. So I'm going to draw a double arrow up the slope, parallel to the slope as well. That's the acceleration of 0.5. There we go, that's a very useful diagram. That should make the rest of the question nice and easy. So we're showing that the mass is 5g over 1 plus g. Let's resolve and let's think about which direction is the most sensible direction in which to resolve. So let's just think about this before we dive in. If we resolved perpendicular to the slope, if we resolved in that direction, how many unknowns would there be? Well, r would be included, and we don't know r at the moment. And m would be included as well. We don't know m. It's m that we're trying to find, which is okay. But there'll be two unknowns, r and m. Please remember, g is not an unknown. We know g is 9.8. So we'd have two unknowns, r and m. Now consider what would we have if we resolved parallel to the slope. And I'm going to go in the direction of acceleration. So parallel and up the slope. If we did that, r would not be included in the equation because r is perpendicular to the direction I'm currently working in. I'm currently working parallel to the slope. R is perpendicular to that, so it won't be included. Therefore, the only unknown will be m. That means that's all we need to do. Resolve parallel to the slope. That'll give us an equation where the only unknown is m, so we can rearrange it and find m. So here we go, let's do that, resolving parallel to the slope and up the slope. First of all, the 5g force. The way I've always resolved forces is two things. Number one, I always go with cos, and number two, it's cos of the angle between the force and the direction I'm currently working in. So this one is going to be 5g cos 60. When I say I always cos, if I end up with cos of 90 minus alpha, for example, then I know I can turn that into sine alpha. That's the way that's always worked for me. There are other ways of thinking about it. For example, in this one we've just done, the 60-degree angle, it is adjacent to the direction that I'm working in. Adjacent, think from SOHCAHTOA, adjacent over hypotenuse gives you cosine. Now I've written cos 60 there. If you somehow wrote sine 30, that would also be correct, because they are the same. So I've got 5g cos 60. After rotating it through 60 degrees, it is pointing in the correct direction, so that is positive. Now for the weight, mg, I'm going to turn that through this angle here, which is also 60 degrees, because angles in a triangle add up to 180, which makes that 60 degrees. It's also rotating through 60 degrees, so it's the force times the cosine of the angle we are rotating it through, and then after rotating it, it's pointing in the opposite direction to the way I am working at the moment, which means it's going to be a minus. If you ended up with sine 30 there, that would also be correct. Sine 30 is same as cos 60. That's it, there are no more forces. All of that is the resultant force F in Newton's second law, F equals ma. So that's the F now equals the mass, which we don't know, times the acceleration, which we do know, of 0.5. All that remains is to rearrange this and make m the subject. Well, I can see m appears in two terms, so I'm going to I'm going to need those terms on the same side of the equation. So I'm going to, well, simplify cos 60. Cos 60 is a half. In fact, I'm noticing that cos 60, which is a half, we've got another cos 60 there, which is a half, and we have another half. So every single term has a factor of 1/2. So I'm going to double the whole equation, both sides of the equation. I'm going to double them all. So I just said I'm going to double both sides of the equation. Of course, that's the same as dividing both sides of the equation by 1/2. And the effect is it cancels out these three terms. Dividing by a half or doubling both sides, they all disappear. So that makes it a bit nicer to look at. So now I've got 5g, take away mg equals m. I'm going to add mg onto both sides of the equation. Common factor of m. And then I'm one step away. So 5g divided by 1 plus g equals m. Yep, and that matches the show that. Therefore we know we've done it right.